Hello dear students, welcome to a new chemistry session in chapter 0 entitled Chemical Reactions. At the end of this video, you will be able to define molar volume, apply stoichiometric calculations in terms of molar volume, define the yield of a reaction and calculate it. You need in this session a pen and your chemistry booklet. Solids and liquids have definite volume. However, gases don't have a definite volume. They occupy all the available space. But what are the factors that affect the volume of a gas? Consider the following setups occupied by 1 mole of a certain gas under the same temperature. However, more pressure is exerted on the second setup. We notice that they have different volumes. So, at the same temperature, 1 mole of a gas occupies different volumes under different pressures. Consider another 2 setups occupied by 1 mole of a certain gas under the same pressure. However, the second setup is heated. We notice that they occupy different volumes. So, at the same pressure, 1 mole of a gas occupies different volumes under different temperatures. As a conclusion, the volume occupied by a given amount of gas depends on 2 factors, temperature and the pressure. Consider the 2 setups occupied by 1 mole of 2 different gases, H2 and O2. The 2 setups are under the same conditions of temperature and pressure. We notice that they occupy the same volume. This volume is called molar volume. The molar volume Vm of a gas is the volume occupied by 1 mole of this gas. This volume depends on temperature and pressure. Scientists fixed the standard conditions of temperature and pressure STP as follows. The standard temperature is 0 degrees Celsius. However, the standard pressure is 1.013 bars. At these conditions, the molar volume of a gas is 22.4 liter per mole. A sample of a gas occupies 4.1 liters at STP. How many moles are there in this sample? At STP, each 1 mole occupies 22.4 liters. For a volume 4.1 liters, we can know the number of moles. N equal 4.1 over 22.4 equals 0.183 moles. So, N equal V over Vm, where N is the number of moles expressed in mole, V is the volume occupied by a gas sample expressed in liters, and Vm is the molar volume expressed in liter per mole. Let us do an application together. The synthesis of hydrogen chloride is carried out starting with 50 centimeter cube of hydrogen and 10 centimeter cube of chlorine, given that the molar volume is 24 liter per mole. First of all, write the equation of the reaction. H2 plus Cl2 gives HCl. To make this equation balanced, multiply HCl by 2. Is the initial reactant mixture a stoichiometric mixture? Let us convert the volumes into liters. Volume of H2 equal 50 times 10 power minus 3 equals 0.05 liters. Volume of Cl2 equals 10 times 10 power minus 3 equals 0.01 liters. Convert the volumes into number of moles. Number of moles of H2 equal volume of H2 over molar volume. It is equal to 2.08 times 10 power minus 3 moles. Similarly, the number of moles of Cl2, it is equal to the volume of Cl2 over molar volume. It is equal to 4.2 times 10 power minus 4 moles. The second step, we should find the ratios of the reactants. Ratio of H2, it is equal to the number of moles of H2 over 1. It is equal to 2.08 times 10 power minus 3. Similarly, the ratio of Cl2, it is equal to 4.2 times 10 power minus 4. We should compare the ratios now. Ratio of H2 is greater than the ratio of Cl2. Thus, this mixture is a non-stoichiometric mixture. Indicate the limiting reactant. Ratio of H2 is greater than the ratio of Cl2. Thus, Cl2 is the limiting reactant. Calculate the volume of HCl obtained. By stoichiometric ratios, number of moles of Cl2 initial over 1 equal number of moles of HCl produced over 2. By cross multiplication, the number of moles of HCl produced is equal to 2 times number of moles of Cl2 initial. It is equal to 8.4 times 10 power minus 4 mole. The number of moles, it is equal to the volume of HCl over molar volume. By using this relation, we can find the volume of HCl. It is equal to 8.4 times 10 power minus 4 times 24 equal to 2.016 times 10 to the power minus 2 liters. Suppose that 1 gram of A reacts with 1 gram of B according to the equation A plus B gives AB. According to the law of conservation of matter, the maximum theoretical mass of AB that could be obtained is 2 grams. Experimentally in the lab, the actual mass of AB obtained is 1.5 grams. But how successful the reaction had been? Chemists need a measure of a chemical reaction's efficiency to indicate how successful a reaction had been and how much product was obtained compared to the maximum possible mass. This measurement is called percentage yield. It is calculated using the formula percentage yield equal actual yield over theoretical yield times 100%. Where the actual yield is the amount of product obtained from a chemical reaction in the lab. However, the theoretical yield is the maximum amount of product obtained from stoichiometric calculations. The actual yield and theoretical yield are expressed in moles or grams. If the theoretical mass of AB is 2 grams, and the actual mass of AB is 1.5 grams. Thus, we can calculate the percentage yield. It is equal to the actual mass over theoretical mass times 100 equals 1.5 grams over 2 grams times 100% equal to 75%. You have to do this assignment. You should solve questions 4, 5, 6, 7, and 8 from worksheet 2 in your chemistry booklet. Thank you.